Okay, so a diverging lens, what's going to happen is the light is going to come in and be bent away from that center line. So it's going to sort of spread out. So we're going to be able to follow the same rule with these ray diagrams. Flat to focal through the center. It's going to be just a little bit different because if you look, and you can actually kind of see it on here due to the reflection. If you were to trace this line back, okay, it looks as though there is a focal point behind. Okay, boop, boop, boop. You see one that's kind of close there? That's not the real focal point. That's actually because of the reflection of light off there. But it looks to somebody who's over on this other side, so where our observer is, it looks as though the light is kind of all coming from a place over here. So our focal point is on the opposite side. We'd say it has a negative focal point. That's worth memorizing, okay? Diverging. So in these problems, we're going to focus on this focal point when we're drawing our ray diagram. Okay, let's give this a try. The important thing to remember with these is that light bends away on diverging from the center line in a diverging lens. That's the key idea you need to kind of keep in your mind. Okay, there's our robot again. He hates lenses, so he's going to shoot this one. So we're going to go flat, so we're shooting it flat at the lens. And what's going to happen? Well, the light is going to bend away from the center line there. So what we do is we're going to line up between where we're at now and the focal point. All right, we're going to lay our ruler down there. I know there's a focal point over here, but remember the light isn't going to go that direction. It's going to bend away. So we line up, and the light itself is going to go, let's see if I can do this. Oh, sorry, it's really hard without a ruler. The light itself is going to go up like this. Now, I'm going to tell you right now, you're going to be getting a virtual image, so you're going to want to go always with the diverging lens. You're always going to get a virtual, so you got to go backward like that. Always. Then what you're going to do is you're going to go through the center. Okay? So we're just going to go straight through here. Okay? So we're going to connect from this point and the center point, so through the center. So if you were to shoot a ray through here, whoop, didn't do it very well, but there it is. Okay, that means, so you notice over here on this side, on the real side, they don't cross. So you cannot make an image, you cannot make a real image with a diverging lens. Ain't possible. You will see that you have one of these virtual light rays and one of these real light rays meeting over here. So this is on the virtual side. So you would get a tiny little adorable robot right here. Okay, it's on the virtual side. So somebody would have to be over here looking through the lens in order to see it. Okay? Man, my faces always look so stressed out and concerned. They look like they've just seen some things. Okay, anyway, they look through and they see the little robot. Oh gosh, its face went wrong. So it's virtual. It's upright. It's smaller. And here's the great thing about a diverging lens. This is always true for these guys. Okay? No matter where you're putting it, it's going to be virtual, upright, smaller. So this is one of those few nice things that you can just memorize. If you have this kind of lens, you're going to get this. You can also keep in mind that when we had the diverging mirrors, okay, the convex mirrors, they were virtual, upright, and smaller as well. Kind of nice, huh? The only difference was that virtual would have been inside of the mirror, not on the outside. So let me show you an example here. Quick question. Is this guy looking through a converging or diverging lens? You immediately know it's got to be a converging lens. How do you know that? His eye looks bigger, unless, he has some freakish problem with a giant eye. where he's been hit by a magic spell or something. He has a giant eye. You cannot get that from a diverging lens. This guy is holding a diverging lens, and you could tell because he looks smaller in the lens. You can get smaller images with a converging lens, but you cannot get smaller virtual images. You can get smaller real images, but you'd literally have to put a screen down in order to see it. You can't look through a converging lens and see something smaller. You can only do that with a diverging lens. And it's quite obvious when you have a diverging lens. You hold it up, and no matter where you put it, close to your eye, far away from your eye, you're going to basically see this like the same sort of thing. You're going to see a image through the lens, so it's virtual, and it's going to be smaller, and it's going to be upright. When you look through a converging lens, it's going to look different depending on whether you're inside the focal point or outside the focal point, just like those mirrors that I was having you play with the other day. They're very, very similar. One time I actually got a giant box of lenses. I found it in the back cabinet, and they were all mixed together. And luckily, and I don't like to keep my converging and my diverging lenses together because I need them for different situations. So I could very quickly go through and sort them. I would just pick them up and look through them. The diverging guy won't change at all. I can just move back and forth. I'm like, diverging, small, upright, and I'm looking at virtual. Drop it in a thing. So I could sort a huge thing of them within a few minutes. Okay, just keep that in mind.